Alright, so here's the second part of your Chapter 1 exam review. If we start looking at quadrilaterals, a trapezoid is a quadrilateral with one pair of parallel sides. So I would know it's a trapezoid because those sides would have to be marked parallel. Remember, you can have an isosceles trapezoid when those sides are congruent and parallel. Maybe some pictures will help you in your notebook. Okay, if you have a kite, that's a quadrilateral with two pairs of congruent consecutive sides. So consecutive means in a row. My congruent sides are right next to each other. I have a parallelogram, that's a quadrilateral with two pairs of opposite parallel and congruent sides. Kind of looks like a slanted rectangle. Opposite sides are parallel and congruent. Sorry, it looks like a slanted rectangle. Is that what I said? Rectangle is just a parallelogram with four right angles. So opposite sides are parallel and congruent. But now it also has four right angles. Then a rhombus is a parallelogram with four congruent sides. So it's like a slanted square. Opposite sides again are parallel, but all four sides this time are congruent. And a square is a parallelogram with four congruent sides, four right angles, and your opposite sides are parallel, marked by the arrows. So then we looked at the quadrilateral hierarchy to help us stay organized there. Remember, if we found a shape and then traveled down to get to the next shape, those properties are sometimes true. Whenever we're asking those always, sometimes, or never questions, those come from the hierarchy. If I start at this shape, it would always be a quadrilateral since I was moving up in the hierarchy. If I started at a kite, went down, then up to a parallelogram, moving up and down is never true. So a kite would never be a parallelogram. A quadrilateral would sometimes be a trapezoid. A trapezoid would never be a quadrilateral. So if we want to use the circle below to name the following parts, we name the circle by its center point. So the center of the circle here is A, so you could just call this circle A. Your radius goes from the center of the circle to a point on the circle. Here you could have either said segment CE or segment BA, or flip those endpoints around. The diameter then is going the whole way across the circle. It's a segment, it's a chord that has endpoints on the circle. Maybe let's add that in. Let's add in a chord. Chord would be like if we connected D to C there. Both endpoints are on the circle. We have a minor arc, part of the curve of the circle. Since it's minor, it's small, it only uses two letters to name. We could say CD, it has to be less than 180 degrees. A major arc then uses three letters. So we'd be going from B to C to D. You can use that arc symbol there. We need three letters since it's a big arc, more than 180 degrees. And that semicircle is exactly half of the circle. Arc BDC. So you can find the arc measure by measuring the central angle. So if this is my circle, it's a good looking circle. This central angle is an angle with the vertex at the center. and sides pass through the endpoints of the arc. So if I wanted to find this arc measure here, if it was 30 degrees, my angle measure here, my central angle would also be 30 degrees. Then we have these different three-dimensional shapes. Remember that you name a prism and pyramid by the shape of their base. So prisms have two bases. Here this shape has 10 sides. We would call this a decagonal prism since it has two bases that are decagons. This next one is a pyramid. All those points are meeting at one spot. The base is a square. We have to say it's a square pyramid. We can't just call it a pyramid. When you have two bases that are circles, we call this a cylinder. When you have almost like a pyramid, but the base is a circle, that's just a cone. Think of an ice cream cone. This 3D ball, 3D circle is a sphere, just like a globe. And if you cut a globe in half or a sphere in half, we get those hemispheres, half of a sphere. All right, so that's all we have for notes.